Hello everyone and welcome back to our channel Quaint. In this video, today we are connecting two giants of physics, James Clerk Maxwell and Albert Einstein. Yes, you know both the names and both are giants in physics. There's no doubt at all. So, why we are going to connect these two giants of physics? So you know that James Clerk Maxwell discovered four equations in electromagnetism. Though there were contributions of three scientists, Gauss's two laws were there. First one is Gauss's law for electricity, second one Gauss's law for magnetism, third one Faraday's law of electromagnetic induction, and the fourth one, today we know that equation is known as Ampere-Maxwell equation, but originally the equation was only Ampere's equation. And later Einstein made one correction, the correction for displacement current. So that means displacement current, that concept was introduced by Maxwell, and therefore the new equation with the addition of displacement current, the new equation is known as Ampere-Maxwell equation. And jointly all those four equations are known as Maxwell's equations. Whenever we say Maxwell's equations, that means we are talking about all those four equations. Anyway, so not only this discovery of displacement current, one more thing Maxwell did, and that is what? He combined all those four equations and discovered the speed of electromagnetic wave, which is given by 1 by root over of mu 0 epsilon 0. So you can see the expression for C. C here, not only light, it is C here in general electromagnetic wave, means the speed of electromagnetic wave. So C is equal to 1 by root over of mu 0 epsilon 0, where mu 0 is permeability of free space and epsilon 0 is permittivity of free space, and both are constants of nature. Yes, mu 0 and epsilon 0, both are constants of nature. That was known at that time, and C depends on only these two constants and nothing else is there. But you know that according to Newton's mechanics or Newton's dynamics, again Galilean theory is there. So according to them, what is known to us? We know that, say for example, a train is moving and you are traveling in that train, and if you throw a stone in the forward direction, then for an observer standing on earth, means that observer is not on the train. So for that observer, what is the speed of the stone? It is the speed with which the stone was thrown by the man traveling inside the train, plus the train's velocity or train speed. So here you can see speeds are being added up. Again, sometimes it may be required to subtract the speeds. Say for example, if the same man throws the stone in the backward direction of the train, so in that case there will be a requirement for subtracting the speeds. That means the stone speed depends on the source's speed or the observer's speed. Okay. So that was known to us. At that time, all the scientists know that thing. Galilean mechanics, Newtonian mechanics. And according to them, speeds need to be either added up or subtracted. But here, by looking at this elegant equation, C is equal to 1 by root over of mu 0 epsilon 0, Maxwell concluded that speed of electromagnetic wave that does not depend on source's speed or source's velocity or observer's velocity, or motion, better to say motion. The speed of electromagnetic wave does not depend on observer's or source's motion. Okay, then Einstein, and this discovery was made by Maxwell in 1860s. Okay, 1860s, and you know, Einstein discovered his special theory of relativity in 1905. Almost there is a gap of 45 years. Actually, at that time, many people were there, many scientists were there who were going against the statement of Maxwell, because at that time Galilean theory was popular, Newtonian theory was popular, and for that reason many scientists were going against Maxwell's statement. But Einstein looked into the equations carefully, he observed everything, and he concluded that Maxwell is correct. Maxwell is correct. We need to change something else. So instead of changing the Maxwell's equations, Einstein changed the concept of or the reality of space and time. According to Einstein, time must move either slow or fast depending on the motion, time itself, and space also same thing. There will be a contraction or elongation in length depending on motion. These are relative. Means that according to Einstein, space and time are relative, but up to that time it was known to all that space and time are absolute concepts. But Einstein made this drastic change in the concept of space and time. Okay, he didn't make any attempt to change the Maxwell's four equations, and therefore the result is known to you. Einstein discovered special theory of relativity and published in 1905. Okay, that means what? That means we can consider Maxwell's equations as the blueprint for the theory of for Einstein's theory of special relativity. Yes, Maxwell's equations, depending on Maxwell's equations, Einstein predicted all these things. According to Einstein, speed of light does not depend on source's motion or the observer's motion. Okay, so now you know that Maxwell's equations laid the foundation for this special theory of relativity of Einstein, and this was the connection between those two giants in physics. Okay, James Clerk Maxwell and Albert Einstein. Anyway, so this was all about today's topic. And one more thing I need to say here, that is E equal to mc square, that idea or that equation, very important equation, very beautiful equation. That equation we got from special theory of relativity. So you can say that E is equal to mc square came from Maxwell's equations. So no doubt that Maxwell's equations are the blueprint for special theory of relativity of Einstein. Anyway, so this was all about today's topic, and if you found this fascinating, please like, share and subscribe to our channel. So this is the end of this video. Thank you for watching this video.